what we are doing today is the all-important and very fun geometry concepts. Okay, so for those of you that haven't started geometry yet at school, geometry is a part of maths where we have to be able to see what is happening in a diagram. And so what I mean by that is when you start to get geometry questions, it's very important that you look carefully at the diagrams that we have given you, because there will be a lot of information on there. And what, guys, I don't know, whatever, English today is clearly not Englishing, but it's okay. And another thing that you will see when you start to do geometry, or if you have done geometry, is that we will always ask you to give a reason for whatever statement you have made. So for example, if you're going to start to say all angles in a quadrilateral must add up to 360 degrees, that would be a reason for you stating that a certain angle in a quad is however many degrees. So every time you make a statement, or every time you tell me the value of an unknown angle in geometry, you have to give a reason for why you have said that. Now, there are lots of reasons that you are going to learn. Some reasons have to do with straight lines. Some reasons have to do with triangles. Some reasons have to do with circles. But as you go on in maths, like I say, you're just going to start to build on these foundation reasons and examples that we do now. These reasons that you do now, you're going to use in matric. And so as long as you can start to understand the basics now, geometry hopefully will not be the scary section that a lot of people think it is, and it really isn't. All right, so I'm going to do my best, especially because some of you haven't done geometry, to try and, I'm not going to say teach, but to try and just give you the basics as we go along, but also to get through some of these questions and hopefully make you feel more comfortable for your exams. All right, so guys, the first reason that we're going to use in this case, or one of the reasons that we're going to use as we go along in this lesson, and actually I've made some choices, I'm going to do this, is the fact that if you have got angles around a central point, so a whole bunch of angles around one central point, we know that around a point or in a circle, we have got 360 degrees. Okay, that's something we remember from primary school. If we have got a whole bunch of angles around a point, and we add all of those angles up, we will get 360 degrees. You can have 3 angles like I've drawn here, you can have 2, you can have 17, whatever. But if you have got a whole bunch of angles around one common or central point, you have got angles around a point. Right, sort of leading from that, if we were to cut a circle in half and we were to, that is trying to be a straight line, it's just not doing very well today, and we were to just consider angles on a straight line, these angles are what we call supplementary, but basically these angles need to add up to 180 degrees. Now the reason for that is if we just look at our circle, we've got a full 360 degrees here. Here on a straight line, I've only got half a circle. So the number of degrees that I'm working with is half of 360. Another reason that we need to know that it involves straight lines, and we'll chat about some more as we go along, is the fact that when you have like a cross-looking shape, and it can be like a very clear cross-looking shape, or just 2 lines that are intersecting with each other forming a cross, what we need to remember is that the angles opposite each other in this cross shape are equal to each other. And these are what we call vertically opposite angles. So as we go along and as we start to chat about these different statements that we're going to make to say that angles are a certain size, we're going to have to also give reasons for every statement that I'm making. And so what we've sort of started here on the side are going to be our reasons that we're going to use. All right, but if we go back to the questions and we start to have a look here and see how we can start to answer these, if we start with 1.1, we can definitely see that we've got angles around a central or common point here. And we know that if we were to add every single angle up here, I must get 360 degrees. Now, this is where looking at the diagram and being very critical of what you're looking at is very important. Yes, I could use angles around a point, but I need to remember that I don't know this angle with the star. I don't know X, and I don't know Y. So there's 3 angles that I don't know, which means it's a bit of a problem to try and find one of them. So now we need to look very carefully and very critically at our diagram to see if we can find some other way for us to work out what X and Y are. So if we go and have a look at this segment or this part of my diagram, RP, what I see is that RP is a straight line. And if I go and have a look at, let's go MN, whatever, MN is also a straight line. And so what we know is that the angles that fall along the straight line, so in the case of the blue that I'm highlighting, Y and 110, because they are on a straight line, they should add up to 180 degrees. So I can make a statement here that I know Y, plus 110 degrees must give me 180 degrees. Right, now, very importantly, grade 8s, you have made a statement, which means that you have to give a reason. Now, if you know you are someone who forgets to give reasons, which some of us do, especially when we start out with geometry, what I suggest you do in your exam is you split your answering space in 2. You've got a space for your statement, and then you've also got a space for your reason. And hopefully if you set your page out like this, because you've got reason right there, you're not going to forget to give your reason. So remember, our statement was the fact that for the first bit, Y plus 110 degrees must give me 180 degrees. And the reason I am saying this, why am I saying that this statement is true, is because, okay, my screen's decided to have a life of its own for a second, is because we have got angles on a straight line. Now, guys, remember, mathematicians are quite lazy when it comes to writing things down. They're not really big on full words and full sentences. So what's quite nice about geometric reasons is that you can start to abbreviate certain parts of your reason. Everything that I'm abbreviating here, you are welcome to abbreviate. If you want to write out angles and straight, that's fine. But you don't have to, not with geometry reasons. So just so that you know exactly what it is you're seeing here, this little sideways L looking thing, hopefully we remember that from junior school. That is a symbol that we sometimes use for angles. And this STR abbreviated is straight. So angles on a straight line. And you can abbreviate both of those as I have done it here, because this is maths, we're not writing an essay. We don't need to spend more time than necessary writing things down. Right, we obviously haven't answered this question. So we still want to go and solve for Y. And hopefully what you see here is that you've got a nice, easy equation that you can go and solve. So according to my rules of solving equations, we know that we need to use inverse operations. So I would need to subtract 110 degrees on both sides of this equation to isolate or to solve for Y. And so what I have in the end, once I subtract 110 on both sides, is I have got 70 degrees. So what I've just worked out is that this angle labeled Y is a 70-degree angle. Right, that's one of our angles, but I still have X that I need to work out. So again, if we go back to our diagram, we can see that X is on the straight line MP. And if you don't know what I'm talking about, look at the purple highlighted line. And once again, we have got angles on a straight line. I know that 70 plus 83 plus X must give me 180 degrees. And of course, I haven't left myself enough space, so I'm just going to go on the side here. Remember, we're making a statement, and then we have to give a reason for that statement. Anytime you write a new idea or a new statement down in geometry, you need to give a reason. Our statement is that X plus 70 plus 83 degrees must equal 180. I haven't left myself much space, so I do apologize, but we get the picture. And then we can start to solve for X. Now, guys, there's lots of different ways that you can do this, and it's really up to you, but remember the goal is to get X alone. Before I start solving for X, remember I have to give a reason, and once again, I've used the fact that I have angles on a straight line. Now, grade 8, very importantly, before we finish this off, please remember to write down your reasons, especially in grade 8 and grade 9. You often get a mark for a reason. And so if you've got a question like this one, where you have a total of 4 marks available to you, and I know it's 4 marks because I have put a mark allocation for you. These 4 marks are coming from you making a statement and giving the correct reason. Making a statement, giving the correct reason. If you forget your reasons, you have lost 50% of the marks in this question. And that's a really silly reason to be losing marks. So please remember to write down your reasons for your statements. Right, we still need to solve for x, so we would subtract 70 and subtract 83 from 180 degrees, and we get that x is equal to 27 degrees. And so based on the 2 values that I needed to determine here, we have found x and y using geometric reasons. Right, just quickly, there was a question on the chat of, can we also call them perpendicular lines? Vashali, I think what you are talking about is this last reason that we had here, opposite angles are equal. They don't have to be perpendicular. Grade 8s, please remember that perpendicular lines is a very special type of relationship whereby the lines cut each other at 90-degree angles. They don't have to be 90-degree angles. Sometimes they are, and that's fine, but they don't have to be. Okay, we will deal with perpendicular and parallel lines as we go along, but these are just our basic straight lines for now, and we will get to those relationships later. So yes, sometimes they can be perpendicular, but they're not necessarily always perpendicular. All right, guys, so if we go and have a look at 1.2, we can see that our diagram looks a little bit different here. And we've almost been given a hint of what to do because we can sort of start to see this idea of a full circle around this common point in our diagram. So if we go back to the reasons that we know that angles around a point must add up to 360 degrees. Now, in this case, I've only got 2 angles. I've got angle F and I've got the angle 226 degrees, but they both are around that common central point there. And so what we know is, remember, again, statement reason. What we know is that F plus 226 degrees should give me 360 degrees. So I can make my statement. I really don't like how much space I've left myself. Let me move. All right, there we go. So my statement again is F plus 226 degrees must give me 360 degrees. And the reason I'm able to make that statement is because I have got angles around a point, and things are just moving here. So give me 2 seconds to figure out why it hates me at this point in time, because apparently it does. Didn't I don't really know what you mean. Are we going to do more? We're doing geometry. So that's what our focus is, because geometry is a big part of paper 2. There are other questions in paper 2, but our focus today is definitely going to be geometry. So again, angles around a point. I'm going to rewrite my statement. Apparently I'm not. I hate technology sometimes. If plus 26 degrees must give me 360. Everything seemed to change anyways, and I've got my angles around a point. Now again, grade 8s, you are welcome to abbreviate things. So this little thingy again is angles, that sideways all looking thing. PT, point. So if you want to abbreviate, you're more than welcome to. Like I say, this is not an English essay. We don't necessarily need full words. Use the abbreviations that your teachers teach you or that I'm giving you here. And so we get that F is equal to 134 degrees. Right, now grade 8s, once again, I'm confused why we're not listening, because a lot of you are saying, I don't understand, but remember the goal. If we just go back to the question, determine the size of the angles marked with lowercase letters. That's what we were doing. As I said in question 1, we're solving for X and Y. So unfortunately, grade 8s, as you know, if you don't listen, you don't know what's going on. So please make sure you are listening to what is going on in this lesson. Otherwise, as I've said many a time, you're wasting your time, you're wasting my time, you're wasting each other's time. Right. So let me deal with all of these issues here. Where did I get 27 degrees? Mikli, I'm assuming you mean from the first question that we did a while ago. 27, I solved my equation. So over here, x is equal to 180 degrees minus 70 minus 83. Because remember, I want to get that x alone. So I need to get rid of the plus 70 and the plus 83. I'm solving my equation. So that's where I get 27 degrees. Solofelo, I don't really know what you mean where this is going. My goal is to solve for the unknown or the small letters. That's where I'm going with it. So if that's not what you mean, please try and help me out. And then guys, for 1.2, we have solved for f by once again using our inverse operation. So we didn't want this 126, we only want f. We are solving for f. So we have to subtract 226 on both sides. 360 minus 226 gives me 134 degrees. So this angle F over here is 134 degrees. If you add it up, you will get 360 because you have got angles around a point. All right, I'm stopping there for you to take a screenshot of those questions, and then we'll have a look at some more. If at this point, guys, any of you have questions, you can raise your hand and you can ask. Otherwise, you're taking screenshots. And remember, guys, specific questions. Saying I don't understand or please re-explain, that doesn't help. I want specifically what is troubling you. Nelson?
Yes, ma'am.
Yeah.
I don't actually get how we plus f plus 226 equals 60.
Okay, because remember, I have got angles around the, okay. Nelson, I'm just going to mute you because I'm now hearing my voice and there's feedback, and that's not going to work well for anyone. So remember, you have got two angles around this point here. You've got F and you've got 226. When you add them together, you must get 360 degrees. So I'm using geometric reasons to go and find out the value for F. If I know that F plus 226 degrees must give me 360 because they're angles around one point, I can then go and subtract 226 from 360 and I can get how much F is in terms of its degrees. So Nelson, you can unmute. Does that make sense?
Yes, ma'am. Thank you, ma'am.
Good. Solofelo? Oops.
Hello, ma'am.
Hi.
Yes, ma'am. I don't understand like how you get the point of the degrees and stuff, ma'am.
I've just explained it. So what confused you about my explanation that I just gave?
Ma'am, what confused me is the F.
Yeah.
Because on the previous one, you didn't put like R plus 110 and all that, ma'am. So the F is what confused me.
Okay, but remember F is the little angle that I'm looking for. F is this angle over here that I want. In the question before, I was looking for X and Y. So no, I didn't use R and N and stuff. I used X and I used Y because those are the angles that I'm trying to find here. So the lowercase curly cursive letters, I want to know what size that angle is in order to go and work out the value of F.
Oh.
Okay, so
Yes.
in this diagram, do you agree F is an angle? That is an angle created between two arms. You could put a protractor on here and you could measure that angle. Do you agree?
Yes, ma'am.
All right, so what we're trying to do is we are trying to use geometry if you can't use a protractor, which generally we won't, how can I work out what size f is? And if you have a look here, sort of at what I've drawn, if you include this angle, you have got a full circle. A full circle has 360 degrees in it. So if I've already got 226, how many am I missing at f? And that was my 134.
Yes, ma'am.
Okay. BK?
Interesting, ma'am. Yo, what help me, ma'am? I don't understand 1.1. It confuses me a little bit, ma'am, because
Confuses
the
you.
x, ma'am, the
Why
x,
does that confuse you?
ma'am, because, ma'am, like if you want to find y, ma'am, right, and it's marbled up, ma'am, how can you change? I know you said this, ma'am, but how can you find y and x if they're multiples?
What do you mean if they're multiples?
Like if there are a lot of them, like if there's like one. If
Okay.
there's one.
Right. Okay, grade 8s, we are just going to scrap all of this because clearly we're not following anything. So everyone put your hands down. I'm starting again. And I'm not using those examples, not doing anything. So let's see if we can get this right. Right. Let's mute ourselves. Let's put our hands down. And let's make sure we're focusing. In geometry, you get shapes. We use lines. We can use quadrilaterals, triangles. But geometry is basically the mathematical study of shapes and lines that create those shapes, etc., etc. So if we just start off very, very basically, and we have got a straight line, okay, it is a straight line. I'm just not using a ruler. What we know is that we can add straight lines to this diagram, and we call or create what we call arms that form an angle. Okay, now remember, an angle you can measure using that protractor looking thing that is in your math set, right? We don't really use it anymore. But a protractor measures the distance between one arm and another arm to create an angle. Now, an angle is measured in degrees. So what we are trying to do in geometry 9 times out of 10 is we are trying to work out the size of angles. Okay. So as I've already said, and as I'm going to say again, the 3 sort of basic straight line rules are as follows. We can get angles on a straight line, so really as many angles as you want. Let's call this angle A, angle B, angle C. If you add all of those angles up, so angle A plus angle B plus angle C, essentially what this creates is a half circle. And we know that half of a circle is 180 degrees. And so adding up all of those angles must give me 180 degrees. What that means is if you knew that B was 60, and let's say C was 90, I'm just making up numbers here, you could go and work out what angle A is. Because you know they have to add to 180 degrees, you've already got 60, you've already got 90, how many more do you need to make 180? So this is our reason angles on a straight line. Okay, so angles on a straight line must give me 180 degrees anytime you're working with a straight line. If we extend that a bit more, we can have angles around a point. So let's say we've got this sort of situation going on. I've got angle A, angle B, angle C, angle D. Because they are all created, or because they all sort of come from this common point that we have right in the middle, we know that if we added all of these up, so if I said A plus B plus C plus D, what I'm creating is a full revolution. And so A plus B plus C plus D must give me 360 degrees. Now, again, if I told you what A, B, and C are, you could very easily work out D, because you know that if you add all 4 of them, you must get 360 degrees. This is how angles round a point. Okay, so anytime we've got the central point where we've got angles coming out of it or angles created from that central point, what we have is angles around a point and we can work it out. Our third basic straight line reason that we use is that vertically opposite one. So this is where we're forming this like cross shape. It's not very great cross shape or whatever. We've got this cross shape that forms when two lines intersect or cut each other. And what we then know is that the angles opposite each other, so let's actually use this, the angles opposite each other are then equal to each other. So they are exactly the same size. If this is 100 degrees, that is 100 degrees. If this is then 40 degrees with the dots, the other angle is 40 degrees. If they are at a cross and the angles are directly opposite each other at that point where the lines intersect with each other, they are equal. And this is what we call vertically opposite angles. So these are three basic straight line rules that we use that we then need to be able to use to answer, find the missing value or find the missing angle X, find the missing angle Y, etc., etc. Okay, so Didn't you said why, what, why, what? Please give me a proper question and I can help you. Right. Okay, so as Hugo has said, anytime that you are working with these scenarios, they are true. It's not necessarily that it's only true if you have, I don't know, like a 90-degree angle. If you have got angles that all fall along one straight line, you will always have angles that add up to 180. If you have got angles that are all situated around one point, they will always add up to 360 degrees. And anytime you've got two straight lines crossing each other, the angles opposite each other will be equal. Didentle, are you sure? Because now we're going to try these questions again. Okay, cool. Right, so guys, if we go back to where we were and we attempt question 1 again. For heaven's sakes, now I've just gotten rid of it. Okay, so here we are. We've got our diagram. The question says, determine the sizes of the unknown angles. So let's start very, very basically by figuring out where are these unknown angles. Well, I've got one unknown angle here at Y, and I've got a second unknown angle at X. Okay, so I need to work out the size of those two angles in my diagram based on the information I have been given. Now remember, in geometry, as we've seen, anytime you're going to say that I know that if I add these angles or if I times these angles or whatever, anytime you make a statement, you must give a reason. So if you need to split your page, statement, reason. And we can now go and work it out. Now, guys, you can start with whatever angle you want. I honestly don't care. But we need to look, and this is what I said right at the start, we need to look carefully at our diagram to see what information we have been given. I have been given two longer straight lines, I suppose we can say, and a slightly shorter straight line. So if we go and have a look at our diagram, I can see that one of the straight lines that I'm working with is MN. So this one I'm going over in red. If you now ignore everything else, so ignore, oops, I'm a bit aggressive with my crossing out. So ignore everything over here. We'll come back to it. And you just look at what is going on in this section of our diagram. What we see is that we have got angles on a straight line because we have that straight line MN. And we know that if we say Y plus 110 degrees, I have to get 180. Because as Hugo said, reason is always as important as your answer. Our reason angles on a straight line. And because I know that fact is always true, as Hugo said there on the chat, we can now go and solve for Y. So according to equations, rules of equations, we use inverse operations. So I'm going to subtract 110 on both sides because I want to solve for y, and I get that y is equal to 180 minus 110. Now I don't have to give the reason again. This is all part of the same working out. And so y is equal to 70 degrees. So now I know that this yellow angle, that y angle, is 70 degrees in size. Now this makes sense. If I now go and work again with those angles on a straight line, and I say I've got y and 110, 70 plus 110 is 180 degrees. So I've got angles on a straight line. So now I've worked out one of my unknown angles. Now I know what y is. Because I now know what y is, hopefully that's going to help me find x. So again, I look at what my diagram has given me. Everything we give you in a diagram has some importance. And I see that I've got this other straight line RP. So now if I add up all of these angles on my straight line, 70 plus 83 plus x, I must get 180 degrees. So again, I make my statement and I give my reason. My statement is that x plus 83 plus 70 must equal 180. My reason is because they are all angles on a straight line. And if I add them up, I must get 180 degrees. Now, because I have to solve my equation, so this is now the inverse operations that I'm talking about. Inverse operations is how we solve an equation, guys. This is how we solve equations. So if you've done equations, you should know how to do this. My goal is to get x alone. So I need to get rid of this plus 83 and that plus 70. To do that, need to take them to the other side of my equal sign. What that means is that their signs need to change. So this becomes minus 83 minus 70. They both were positive, but because they're moving over the equal sign, they now both become negative. So I've got x equals 180 minus 70 minus 83. If you said minus 83 and then minus 80, absolutely fine. That doesn't matter. And when you subtract those from 180 degrees, you get that x is 27. And so what you found here is that angle x has a size of 27 degrees. Okay, so Awam, I hope that makes sense. Let us stop here. If anyone has any questions, raise your hand. Otherwise, we will try and have a look at 1.2 now. Awam, I'm glad it makes sense. Well done. So it's solving an equation. Yes, we're doing it in geometry, but we are basically solving an equation, and that is part of algebra. Okay, grade 8's questions. If we have them, let's ask them. Because I can say you're going to use this stuff all the way up until matric. Andile, why would you use 90? Where in this diagram have we said that there is a 90 degrees that we can use? So if you can explain to me why 90, then we can chat. But right now, where do we have a 90 degrees? See, clearly, no, there are many, many more reasons. We are just focusing right now on these three. Taboko, it's not all S, it's angles. Remember in primary school, you use angles as your symbol, so angles. BK?
Oh, now I understand, ma'am.
Okay,
So
good.
ma'am, if you want to find the y, you just say 110 minus 180, basically.
Yes, exactly, because they are on a straight line.
Interesting.
Okay, there was a question as well. Can we say 360 minus 110 minus 183 divided by 2? No. So if you did that, you are assuming that these angles are equal, and they're not. I haven't told you that they're equal. There's nothing there that indicates that they're equal, so we cannot assume that we can just divide by 2 because that would be wrong. All right, we need to make sure that we're not making any assumptions about our diagram, and this is why I'm saying we can't use 90, because nowhere have I told you that there is a 90-degree angle. If I did, then absolutely, but I haven't in this case, so we need to be careful. So Sisipo, I think it was, yeah. Sisipo, I hope that makes sense. We can't just divide it by 2. Just because we have 2 unknowns does not mean they are the same, and they probably aren't the same because they have 2 different letters. X and Y usually represent 2 different values. Okay, Andile, okay, so in geometry, yes, again, you can use 90 in geometry, but only when I tell you that there is a 90-degree angle. If I give you a specific case where we use 90, you can't just use it any way you want. All right, so let's see 1.2. Let's try again. Let's go back to what I wrote down here. We've got 3 reasons. We have used angles on a straight line so far. If we look at reason 2 that we have sort of chatted about so far, reason 2 says to me that if I've got angles around one common point, so all of these angles around one common point, it creates a circle for me. And so those angles must add up to 360 degrees. So let's look at 1.2. What I see here is that I have got 2 angles. The angles look a bit different to what we used to, but they're angles. We've got this reflex angle 226, and we have got this angle F. Now, if you look at the pink shape I've drawn, that's a circle. And so what that means is that if I add those 2 angles together, I must get 360 degrees. I'm about to give up. Right, so there's my statement. There's my reason. My statement is that because if I add this angle F and I add 260 degrees, I'm getting a full circle. So F plus 226 must give me 360 degrees. They are angles created at a common point. Yes, one's a reflex angle. Yes, one is not, but that doesn't matter. There are angles around a central point. And so my reason is angles. So angles, it's not LS, angles round a point. PT is point. I'm just abbreviating, and you can do that as well. And now we solve. So this is now again where our inverse operations come from. I only want F. So I need to subtract 226 degrees. If you don't really like that idea of subtract 226, what you are doing is you are bringing the 226 over. And so it's going to become minus 226. And so F is equal to 360 minus 226 degrees. Again, you don't need a reason. It is the same working out. You're still working with F. And so F is equal to 134 degrees. So now I know this F's angle is 134. If you add together 134 plus 226, you get that full revolution of 360 degrees. Right, Omlemo, I will go back to those reasons now in a second. What I'm going to do first is I'm going to do that so that you guys can take screenshots of those questions. Again, I'm going to stop. If anyone has any questions you need to ask now, one day they can ask you to identify the angle. So we could say identify an obtuse angle, an acute angle, a reflex angle. We definitely could, but we should remember those from grade 7. If not, I am fairly certain that my geometry videos from last year are actually still on Watobe's website. So I definitely go and have a look there if you aren't super comfortable with identifying angles. But they can. It won't be like a massive question. These are more of the types of questions we will ask you. Grade 8, you're screenshotting. You're asking me questions if you have any. And then I'm going to quickly go over to those reasons that you can take a screenshot of those if you would like. Oh, no, okay. Meetly, you can watch the recordings on both Watobe's website as well as YouTube. They get uploaded there. If you just log into your Watobe profile and then you go to your grade, all of the videos are there for you. Atlahang?
Actually, ma'am,
Ma'am?
I just want to mention quickly, sorry, Atlahang, the bootcamp classes will only be available on the website, not on YouTube. The rest of the classes are on YouTube though, but this bootcamp will be available on the website only.
Yeah, sorry guys, I should have distinguished between that because you guys signed up for the bootcamp. Like Hugo says, you have special access to these videos on the web. And then I muted myself. Anyways, Atlahang?
Ma'am?
Yes.
Ma'am, will there still be the Monday and Wednesday lessons during exams?
Yes. So for the rest of the term, yes.
Oh, thank you, ma'am.
Sure. Alrighty, grade 8. I'm hoping that we are okay with the, no, okay. Solofelo?
Ma'am,
Oh, yes.
with Monday to Wednesday lessons, is it still same time? Because now my studying schedule is very busy, ma'am.
It is still the same time. Guys, please let's try and focus on boot camp. Yes, we still have Monday lessons and Wednesday lessons. The times are exactly the same as they have been the whole year. We do understand that you have to study, but it is just an hour of your time. So try and be there. Omolemo, there are those reasons that you had asked for. Sorry, I had meant to scroll over and then I didn't. So Tulafelo, are you happy? The lessons are still the same time. Okay, so guys, here are your reasons. Take a screenshot. Okay, so those are just 3 that we've learned. In grade 8, you learn 10, if I'm not mistaken. So don't it mustn't overwhelm you, but just realize there's definitely more than just these 3, and we're going to do them hopefully as we go along. All right, so I'm going to look at 1.3, and then I think we all need a bit of a breather, and then we will continue on. So if we look at 1.3, again, and actually I don't even want to use what I've done here in 1.3. So don't take a screenshot, don't do anything just yet. I'll scratch those out. And let's use 2x and 120. Okay, so that's a diagram that we're going to use. I don't know why I chose to scratch it out in the black pen. Let me do this. Okay, now guys, what you need to see is, once again, you need to look very carefully at your diagram. What you should be seeing here, based on what I've given you, is the fact that you have got 2 straight lines that are intersecting or crossing over each other. And because of that, yes, we could use angles on a straight line. Yes, we can use angles around a point, but just looking at what I have, okay, most of the time you can use many reasons to get the same answer, but look at what you have. I can see that I have got 2 angles directly opposite each other at the point where those lines cross with each other. And so automatically I should be thinking of this reason of vertically opposite angles. Angles that are vertically or directly opposite each other at the point where 2 straight lines cross. Now, according to our reason, we know that vertically opposite angles are equal to each other. So if we go back to our example, we should now see that, okay, they're vertically opposite each other. They are directly opposite each other at that point where the lines meet. And so I can now make the statement that those angles are equal. So I can say 2x is equal to 120 degrees. And I can give my reason that this is because everything is fine. Everything is not fine. I'm going to try again. And I can now give the reason vertically opposite angles. Third time's a charm. Vert op angles. Remember that little L thing, angles are equal. All right, so again, I see that I've got two straight lines crossing with each other. I see that the angles that I've been given are directly opposite each other where those lines cut. And so what that means is that I know that those angles are equal. My equal sign is weird. Okay, I know they are equal. They are equal because they are vertically opposite angles. They are angles directly opposite each other where those lines intersect. Now, again, we want to solve for x. Now, this goes back to our solving equations. We've chatted about how we can move values over an equal sign, but in this case, this is a little bit different. We need to remember that between this 2 and the x, there is a times. So if I want to get rid of something that I'm multiplying, I need to do the opposite operation. So if I divide this by 2, those 2's will cancel. But remember, our rule of equations is what you do to one term, you need to do to all of your terms. So I also need to divide the 120 by 2. And so what I get now is the fact that x is equal to 120 divided by 2. And hopefully we know that 120 divided by 2 is 60. Now, guys, you can go and double check yourself. You can go and see if this makes sense according to what you've done. The very first statement that you made was the fact that the angles were equal to each other. So if we go to our diagram, we're saying that this angle 2x is this equal, rather, to that angle 120. If you substitute your value of x in and you say 2 times 60 degrees, that gives you 120. 120 is equal to 120. And so we have correctly solved for our value of x here. So take your screenshots, guys. If you have any questions, now is the time to ask. If you don't have any questions, we're going to take a break until 4, so 4-minute break. I will put a brain break up for those of you that want to try, but honestly, I'm fine if you just need to take a few seconds and absorb all of this information. Meatley, you need to divide by 2 because remember, we want to get x alone. I don't want 2x, I just want x. And so what that means is I need to get rid, I need to get rid of that 2 in front. And we always do the opposite operation. So like Hugo said there, it's the inverse of, or the opposite of multiplication is division. And so we need to divide both sides by 2 to get x alone. Okay, I'm just waiting for everyone to take a screenshot. Alrighty. Brain break. Be very careful, guys, of where there are doubles. But otherwise, please just take a second, take a moment. I will go through the brain break in a few minutes. You need to run to the loo, and then we're going to carry on for our last half an hour. I'm going to make our brain break a bit bigger, just because, again, you need to be careful of where you've got 2 flowers or 2 pot plants or 2 leaves versus 1. And then we'll have a look at the answer now in a second. I see there's a question on the chat. And if there was angles around a point, can we still divide by 2? Honestly, it depends on the question. Angles around the point, generally, you're going to be dealing with more than 2 angles. So you're generally not going to just divide by 2. Oh, excuse me. But yeah, again, it depends on the question. The only time you could potentially divide by 2 is if there was a vertically opposite situation. So I'll just make that a touch smaller. If you had something like this and I told you 120 and I gave you X, you could tell me that this angle here is also 120. And then based on that, you could use angles around a point because you know you've got X and X. So then you could divide by 2 if you know all of that. But it very much depends on the question. I hope that helps. Vishali, that's no problem. We completely understand with load shedding, we all have to make plans. No problem. Right, if you're still taking a little break, I'm going to give you another minute. I will then go through our brain break and then we will carry on with some geometry.
Teacher Sam, I'd like to add to what you said to Andile quickly because it will just take too long for me to type now that we have a sec.
Cool.
The fact that we divided by 2 actually has nothing to do with the angle, Andile. That's just some algebra that we had to do to get the answer. So that's not a rule or anything. Yeah, just remember that. That's just the plan that we had to make to solve for X, quick sticks, you know? It has nothing to do with the angle and it is not a rule or anything. That's just the plan we had to do. So we're going to have to make different plans and sometimes you're going to have to divide by 4 or 6 or whatever. So that's not a rule or anything. That's algebra. That's something completely different that we had to do to solve for X quickly. It's nothing to do with the angles, no rules or anything.
Yeah, exactly. Sorry, sometimes I like get stuck in my own head. Sometimes, yeah, our division will be by another value. The 2, like Hugo says, was just an algebraic situation. And now my maths brain has actually just fried. You guys are on top of our brain break today. Oh. Right, guys, does anyone want to raise their hand and try and talk us through this? I'm going to be honest, I don't know what the answer is. Chantal's on it. Atlang. Okay, Chantal, help us out here. Did I even ask? Sorry, I don't know if I actually clicked unmute there. My apologies.
Good evening, ma'am.
Hi.
Hi, ma'am. The first lens is 8 plus 8 plus 8 is equals to 24.
Good.
And the second is 4 times 4 plus 8.
Okay, now guys, just remember, when doing these, we have to take into account BODMAS. So this is why Chantal said 4 times 4. That's the first thing we do, which is 16. And then 16 plus 8 gives us 24. Good, Chantal, keep going.
The next one is 18 plus 18 times 8.
Okay, so now again, guys, remember BODMAS. If these leaves are each 18, the first thing that we need to do is first realize that we've got 2 plants. So 1 plant was 4, so 2 is 8. 8 times 18 is 144. And then only do we add that second 18 to get 162. So BODMAS, please remember that. Good, Chantal, keep going.
And then it's 8 plus 8 times 16.
Okay, so just be careful. It's only 1 leaf. So this would be 9 plus 8 times 8. So 8 times 8 is 64. And then only do we do the plus. So 64 plus 9 is 73. Sure. Well done, Chantal. Do you see the one leaf? Leaf? Yeah, it is leaf.
Yes, ma'am.
Good, well done. Okay, so guys, that's how we do these sort of brain break puzzle things. We we need to figure out what each picture is worth. And this goes back to what Hugo said earlier, guys. This is an idea of algebra. So you've got, if you didn't want to work with flowers, you've got x plus x plus x. So algebraically, you're adding 3 x's to get 24. So now back to that division, you would now divide by 3, not 2, or whatever your coefficient is. So, excuse me, we need to be careful when doing these. Kakleho, yes, there are 2 plants. Remember, 1 plant was 4, so 2 plants are 8. 1 yellow flower was 8. Oh, I see what you're saying. So 1 yellow flower is 8, 2 yellow flowers is 16. Okay. See, I was just on my own mission here. 8 times 16 is 128. Then plus 9 gives us 137. Thank you. I appreciate all of you who are on top of it. Well done. Clearly, my Saturday brain and start of exam brain is not doing the things. Okay. Thank you. Thank you for pointing that out for me. Right, guys, let's go back and do some geometry here. So let's have a look at this question 1.1.4, 1.4 here. Alrighty, so again, look at what you have. Look at what information we have given to you. And remember that just because, yes, we have got angles around a point. Let me try that again. Just because we do have angles around a point does not mean we have to use it. There may be other reasons that we can use. So if I have a look here, the first thing that I am noticing, and just because I'm noticing it doesn't mean that that might be the first thing you notice, but the first thing I see is that I have got this cross shape that I'm going to start looking out for. And so automatically what I know is that these angles opposite each other, so the 100 and the x, are equal to each other. So I can make my statement, and I don't even have to do any working out here, which is quite nice, that x is equal to 100, and then I can give my reason of the fact that this is because they are vertically opposite angles. So automatically, I know what x is. Now from there, there's a couple different ways that you can get y, and it's really up to you. But from there, what I'm seeing next is I am seeing that I have got a straight line. I've got lots of straight lines, but this green straight line I know is going to be useful to me, because if I say 100 plus y plus 40, I know I must get 180 degrees because those are angles on a straight line. So y plus 100 plus 40 is equal to 180 degrees. And my reason here is angles on a straight line. Now, just quickly, what I want you to take note of is because I started with now a new angle. So I did x, I gave my reason, but now I needed to do y. Because I'm now working on a completely separate statement, I now have to give a new reason. Yes, my reasons are different, but they could have been the same. But just remember, once you've dealt with one angle and you now need to make a new statement, you have to give a reason. So every new statement you give, you must give a reason. Now I can go and solve for y. So this is that algebra that we now need to bear in mind, those inverse operations. I want to bring the 100 and the 40 over to the other side. So that means I'm going to subtract 100 and subtract 40. That will leave me with y alone on the left-hand side. So y is equal to 180 minus 100 minus 40. Let's focus on what I'm doing, please. And so y is equal to 40 degrees. And so now I've got the values of my unknown angles in this diagram. And I've just written 40 next to 40 because clearly I've lost it. 40, there we go. So now I know X is 100 and Y is 40. Okay, so whenever you are making a new statement, you have to give a new reason. And please remember to look very carefully at your diagram. And if, like what I have done, you need to highlight or draw on your diagram to help yourself, do that. There's nothing wrong with that. But make sure that you are considering all of your options available and you're not making too much work for yourself. Right, screenshots. And if you have questions, now's the time to raise your hand. Otherwise, we're going to have a look at another one. Okay, I'm hoping you've all got your screenshots, guys. Oh, not yet. Okay, sorry, Atlahai. There you go. Let's take those screenshots because we're going to move on. Cool. Right, so yes, I'm jumping a bit, but I want to just have a look at 1.6 here because now, those of you that were really excited to work with the 90 degrees, now we have a situation like that. And this is another thing that you also need to look out for on your diagrams. And it's something that we can give you that we expect you to know what it means. So firstly, hopefully what we're seeing here is that we have got a new symbol on our diagram, which is the square over here. Now this square actually represents a very specific angle. This square means that this angle is 90 degrees. Now someone right at the beginning of the lesson asked about perpendicular lines. This is essentially what it's telling you. It's telling you that these two straight lines that I'm highlighting here in red are perpendicular to each other. They intersect at 90 degrees. So guys, when we give you a diagram where we have given you the square shape, we are expecting you to know that it means that that angle is 90 degrees. We're not writing 90 there. We've put the square there. We expect you to know that. Okay. So again, what we now need to be careful of is in this diagram, or rather the only number I've actually given you and haven't even put the number there is the fact that this angle is 90 degrees. That is it. I am asking you to find three different angles. I want X, and that's including the 5X over there. X represents the same thing. I'm also looking for Y, and I'm also looking for the third angle, which is Z, which is this angle over here. So at the end of the day, I need to have the value of three unknown angles here. So let's set up our page, statement reason. And now grade 8, you can start with whichever value you want. It really doesn't matter. Usually we try and start with X because your teacher has probably made it so that you need to start with X. But honestly, if you see something else first, start with that. As long as we have all of your answers, we don't care. In this case, I am going to start with X. And the reason I'm going to start with X is because I can see that I have a straight line here. So here's my straight line. And X and 5X are angles on a straight line. So I know that if I say X plus 5X, I must get 180 degrees because these angles are angles on a straight line. Okay, now I can start to solve my equation. Now guys, this goes back to algebra, and we've done algebra quite a bit just in our Watobe classes, and you would have done a lot of algebra at school. Remember, terms that have the same variable and the same exponent are what we call like terms. So here, X and 5X both have X's, both x's have an exponent of 1, so they are like terms. So I can add them together to get 6x. So 6x is equal to 180. This is going now back to what Hugo was talking about in terms of our algebra and how we don't always have to divide by 2. It can be any coefficient. I want x alone, so I need to divide both sides by 6. That will get rid of that 6. If I now continue, I've got something. We'll get there. No. I have now got 6x equals 180 degrees. And to solve for 180, I need to divide it by 6. So x is equal to 180 divided by 6. 180 divided by 6 is 30 degrees. So what I now know is that x is 30. So this 1x alone is 30 degrees. This would be 5 times 30, which is 150 degrees. Now check yourself. 150 plus 30 does equal 180. So you have correctly used your angles on a straight line there. So that's x. We still have y and z to go. So if I now go and have a look at the next thing that I know I've been given, let's use some rainbow here. I can see that I've got 2 lines intersecting with each other, forming a cross. So those like rainbow sparkly lines that I've drawn there, and actually I don't like that at all. Let's make better choices here. So let's go this yellow orangey color. So if we go to these 2 straight lines, they're forming a cross. It's a weird looking cross, but it's a cross. And so we know that this angle x is equal to this angle y. They are directly opposite each other at the point where the lines meet. So I know that y is equal to x. Drawing my line. My reason is vert-op angles are equal. And because we've worked out what x is, I know that y is equal to 30 degrees. So now I've worked out from my diagram that x is 30 degrees. There was a question about how did I get the 6? It has been answered. But to tender, how did I get 6? X plus 5x, they are like terms. And so if I've already got 5 x's and I add another x, I have 6x. So 6 is coming from the adding my like terms. Plug in here. Alrighty. So I've got x, I've got y so far on this diagram. Now I still need z. Now there's lots of different ways that you can go and do z, but let's have a look. I can see that I've got the straight line here in blue. And I know that if I add 30, z, and 90, I will get 180 degrees. So I'm just going to do this on the side here. My statement is that 30 plus z, plus 90, everything's gone wrong, must be equal to 180 degrees because they are angles on a straight line. So that is my reason that I will give. Now I can start to solve for z. So remember, I'm not a huge fan, or I don't want the 30 and the 90 on the left-hand side. I want them to move over. So I will subtract 30 and subtract 90 degrees from 180. And so z is equal to 180 minus 90 minus 30 degrees. So 180 minus 90 is 90. 90 minus 30 is 60. So this angle of z is 60 degrees. And all I've done, once again, is used my reasons that I know. Angles on a straight line, vert-op angles. Sometimes we can use angles around a point. In a situation like this, you could have definitely found z using angles around a point. Again, it all goes back to what do you see in your diagram and how can you use the information that you have in order to work out whatever it is that you're missing. So take your screenshots. If anyone has any questions, now is the time to raise your hand. Excuse me. And then hopefully we've got time for one more, but we'll see how we go. So guys, screenshots. I've also said take screenshots and then it'll show you the whole answer in mind. So there you go. There's the whole answer for 1.6. Take your screenshots. Guys, I really need you to listen. Like we're nearly at the end and I'm repeating myself for the third time. So how did we get the 6? We added the like terms x plus 5x. That gives me 6 x's. So the 6 is coming from adding like terms, and it is then the coefficient that we need to divide away. Right, you all should have your screenshots at this point. Okay, I'm just gonna make up my own question here. Right, let us have a look at another one, and hopefully we can try and do this a little bit by ourselves, but let's see how we go. Okay, so let's have a look at this question. I've given you, what have I given you? I have given you one angle, and then I've asked for W, X, Y, and Z. So if we have a look, the first thing that I see, like me personally, that my eyeballs are seeing, is that I've got this cross shape. Now, because I've got this cross shape, I know that 70 and Y are equal to each other. So if I start to set up my answer for myself, remember, statement reason. Our first statement is that Y is equal to 70 degrees because of vert-up angles. Now guys, as you've seen, if you've been paying attention, is that as I start to find angles, I like to put them in on my diagram because it's going to help me figure out the next angle, because now I've added more information to my diagram. Right, so the next thing that I'm also seeing here in my diagram is the fact that, and I have no labels for my lines, but that doesn't really matter, is that I've got one straight line that's now this weird pinky green looking color. And that therefore means that 70 and Z are angles on a straight line. And so what I know is that Z plus 70 degrees must give me 180 degrees. And this is because of angles on a straight line. I can now solve for Z. Remember, I'm going to use my inverse operations. I'm going to subtract 70 on both sides, or I'm just going to subtract 70. You don't really have to consider it, English, right? And so I get that Z is equal to 110 degrees. So now I fill that in on my diagram in the hope that this is going to help me get to my next angle size that I want. Okay, so now what we need to be very careful of is the fact that, and I've already made our lives hard here, haven't I? 70. I have to give us this angle. Right, let's say that's 50. Right, so there's Z. Now I need to still go back and find X. So now you could do this in a couple different ways if you wanted to. You could use vertically opposite angles. You could use angles on a straight line. You can use angles around a point, whatever floats your boat. But because we haven't used angles around the point in a while, I'm going to do that one just to revise and refresh in your memories what that is. I now know that I've got 70, 110, 70, 50, because I needed to give that to you. And the only angle I'm missing is X. If I add all of those together, I've got angles around a point. And so what that means is if I go and set up an equation to say X plus 50 plus 70 plus 110 plus 70 must give me 360 degrees, I can in fact use angles around a point. Okay, and I could do that because I had every other angle except for this little angle X around that central point in the middle. So now I go and solve my equation. So I bring everything over. So X is equal to 360 minus 50 minus 70 minus 110 minus 70. And guys, remember, you should be allowed a calculator. If you aren't, just go step by step. 360 minus 50 is 310. Then we have to subtract 70, giving us 240. Then we subtract 110, giving us 130. And then 130 minus 70 is 60 degrees. I'm just going to double check my maths there, just in case. See, 70 degrees. Right, so X is equal to 70 degrees. So I've worked out my last one. You don't have to use angles around a point. There's many other ways you could do it. You could use angles on a straight line. Like I said, you could use vertically opposite angles. There's often different reasons we can give to get exactly the same answer. But it all depends on what you're seeing in your diagram and what information you have to eventually get you to where you need to be. All right, question on the chat: in geometry, will we work with negative numbers? Not really. Angles, at this point, we generally only work with positive angles. You can get negative angles, but that's not something we deal with in grade 8 and grade 9. So most of the time, you're going to be working with positive angle values in terms of your calculations. It's not to say we can't be a bit ugly and give you a negative, but most of the time it's going to be positive. Right, so people, just be careful. Z is not equal to 50, because if you were looking for vertically opposite angles, if you go back to the green lines that I've highlighted, it is this whole angle, the 70 and the 50, that is vertically opposite to Z. So 70 plus 50 is equal to Z, and 70 plus 50 is equal to 110 degrees. So good eye for thinking about vertically opposite. That's very nice. And that was one of the other reasons you could use to get X. But just be careful, it's the whole angle 70 plus 50 that is vertically opposite. But well done, good spot on the fact that there's a third reason that we can have here. Right, grade 8, so I hope you've all taken your screenshots. We've got 4 minutes, so if there's any questions anyone wants to ask, please do so now. Yes, indeed. Guys, maths. What on earth am I doing here? Can anyone spot my mistake there? So there was a question of isn't 70 plus 50 120? It is indeed. So where's my math gone wrong? That's 140, 250. Oh, guys, because I can't work out X. And you all even put X equals 60 on the chat. I've just like gone into my own world here. So there we go. And then 60 plus 50 is 110. Luckily, everyone is on it today except for me. Well done. You did all put 60 on the chat. It shows that I looked at those 60s and my brain did not decide to register anything. So well done. But essentially, guys, you solve your equation. You've got vertop angles, which you can still use. And like I say, because these are vertop angles, 60 plus 50 and the 110, those are the ones that are equal to each other at that cross. And as we have now corrected the math, 60 plus 50 is 110. So they are the same. You did all put 60. Well done. Clearly my brain is tired after this term. Right, guys, if you've got your screenshots, you're welcome to head on off and enjoy the rest of your Saturday.